Hello, I'm Miss Jones, and welcome to my channel, Miss Math Jones. Today, we're going to be working on our STAAR homework packet number 2, and this is your homework helper video. Let's get started. Now, the homework this week is a little different. It's not set up by day. You have 3 pages of homework. And remember, you're not required to do all of the homework at one time. Do it a little bit at a time, all right? So right now, we're going to be going over homework page number 1. And it's okay if you do a few questions each day and then come back to the video to check your work. Let's get started. This is what your first page of your homework should look like. So before you get started, make sure that we're on the same page. So this is what page 1 of your homework should look like. If you're not on page 1, when you start reviewing this video to make sure that you've done the problems correctly, make sure that you're on this page. Let's go ahead and get started with question number 1. Question number 1 says, Teresa wants to read a 400-page book in 3 weeks. She read 125 pages the first week. She read 135 pages the second week. How many pages does Teresa need to read in the third week to finish the book? Now, as always, I want you to pause the video to try to solve the problem on your own. Next, you can check your work as I model the problem. Okay, let's take a look at how to solve this problem. Just like in class, you want to take it one sentence at a time. So we start at the beginning. Teresa wants to read a 400-page book in 3 weeks. I don't see any each or groups or anything like that the first time that I read the problem, so I know I don't need a Gantt chart. But if she read a 400-page book in 3 weeks, then to me, that sounds like I need a strip diagram. So the first thing I'm going to do is write my total as 400-page book in 3 weeks, because obviously that's our total. That's what she wants to do in 3 weeks. That's her goal. Then it says she read 125 pages the first week. So in my first box, I'm going to write 125 pages the first week. The next bullet point says that she read 135 pages the second week. In my second box, I'm going to have 135 pages for the second week. Now, the question asks, how many pages does Teresa need to read in the third week to finish the book? Well, I don't know, but I am trying to figure out how many pages she needs to finish. So I'll write that in my third box. Now, we've worked with strip diagrams a lot. And as you know, when we're missing a number, we need to add the 2 numbers that we have together first, and then we subtract that from the total. So let's add the 2 numbers that we have first. So we have 135 plus 125. And as always, we start with our ones place. 5 plus 5 is 10. I write my 0 in my ones place, and I carry my 1 over my tens place. 1 plus 3 is 4, plus 2 more is 6. And 1 plus 1 is 2. So, in the first part of the problem, you should have 260. Now we have to subtract 400, which is the total, minus 260. Notice how I keep my numbers lined up. I start with the ones place. 0 minus 0 is 0. If I hold up 0 fingers and I try to take away 6, I can't. So I'm going to have to borrow. I go to the hundreds place and I borrow 10 tens, which 10 tens equals 100. So instead of 400s, they now have 300s. And instead of 0 tens, since I borrowed 10 tens from the hundreds place, I now have 10 tens. So now I can continue to subtract. 10 minus 6 is 4. And 3 minus 2 is 1, which means the amount of pages that Teresa needs to read in the third week to finish the book is 140 pages. Now, if that's not the answer that you received when you completed your work, I want you to go ahead and write this out. All right, there is scratch paper attached to your homework packet so that you can work out the problems. So make sure that you write the notes on your paper. That way you have the correct way to solve this problem. Let's take a look at question number 2. Question number 2 says a herd of 10 horses and 8 cows will be taken to a farm in trailers. There will be 6 animals in each trailer. How many trailers will be needed to take the horses and the cows to the farm? A, 3, B, 6, C, 4, or D, 8. Go ahead and pause your video right now to try to solve the problem on your own. Next, you can check your work as I model the problem. All right, let's take a look at question 2. A herd of 10 horses and 8 cows will be taken to a farm in trailers. So I have 10 horses and 8 cows. So when I see that, that means I need to combine those because those are the animals that are going to be taken to the farm. And I have a keyword here of and. So that means I need to add. All right, so now I know I need to add, but I still have more words. So let's see what else we have to do. There will be 6 animals in each trailer. So now I know I'm going to need a get chart. So this is definitely a two-step problem. I have to add and I need a get chart. How many trailers will be needed to take the horses and cows to the farm? All right, so let's get started. I'm going to start by adding 10 plus 8. That's easy math, right? So what's 10 plus 8? That's right, 18. Okay, so now that I have my total number of animals, what I can do is put that information in my get chart. So 18 goes in total. So once I put 18 in total, then I have to look to see what other information I have. Now, it said that there will be 6 animals in each trailer. So that means that my 6 goes into each. Well, now I have enough information to write equations to help me solve the problem. So my first equation would be blank times 6 equals 18. Or I could write it as a division equation, which would be 18 divided by 6 equals blank. Now, we should be able to solve that in our head. But if not, you can use a ratio table to help you figure it out. So I make a ratio table, 4 times 6. And I have my little counters there. And so I'll just number it to, let's say 4. All right. And we start from the top. Well, what's 1 times 6? That's right, 6, because anything times 1 is that number. And all I have to do is keep adding 6 more. Well, 2 times 6 is 12. And I know that because 2 sixes, or 6 plus 6, is 12. Now, if I add 6 more to 12, I get 18. And if I add 6 more to 18, I get 24. But I don't need to because my answer, or my total, is 18. So the number that's next to my total is my answer. So that means that 3 times 6 equals 18, or 18 divided by 6 is 3. I circle my answer of A because that's where 3 is. Now, if that's not the answer that you received when you worked out the problem, I want you to go ahead and write these notes down on your paper so that next time you see a problem like this, you will be able to answer that problem correctly. Let's take a look at question number 3. Question number 3 says, Tycho drew the figures below. Which list describes the figures? So you have to look at these figures and name them. So that way you know which list is correct. I want you to pause the video and write down the name of each of these figures on top of the figures or through them. And try this on your own. Then you can check your work as I model the problem. All right, let's go ahead and name these shapes. So that very first shape at the top, what's the name of that shape? If you said cylinder, you are absolutely correct. Now let's look at the shape right next to it. Do you know the name of that shape? If you said triangular prism, you are absolutely correct. And what about the shape next to our triangular prism? What do you call that shape? If you said sphere, you're absolutely correct. Now let's look at the second row. What do you call that first shape? If you said rectangular prism, you are absolutely correct. And what about the shape next to it? That's right, it's a cone. It's just upside down. It's a cone. So now that we've named all of our shapes, and I hope you named all of your shapes before you started watching me model the problem, now we can see which list actually describes the figures. So answer choice A says one cone. We do have a cone. One cube. Oh, we don't have any cubes, so it's not answer choice A. B says one sphere. We do have a sphere. Two prisms. We do have two prisms, a triangular prism and a rectangular prism. One cylinder. We have one of those. And one cone. We do have one of those. So that means that answer choice B is our answer. Now, if you need to pause your video so that you can write down the names of these shapes and also to circle your correct answer if you didn't answer the question correctly, go ahead and do so now. Question number 4 says, the owner of a restaurant borrowed $6,000 from a bank in order to buy a new oven. A year later, he paid $6,550 back to the bank. Why did the owner of the restaurant pay the bank $550 more than he borrowed? A says the $550 was a gift to the bank. B says the $550 was the sales tax he had to pay on the oven. C says the $550 was the interest he had to pay for the loan. D says the owner must have forgotten that he only borrowed $6,000. Now, for these types of questions, you have to figure out which one makes the most sense. So go ahead and think about that and pause the video to solve the problem on your own. Next, you can check your work as I model the problem. Let's take a look at question number 4. Now, the owner of a restaurant borrowed $6,000 from a bank in order to buy a new oven. A year later, he paid $6,550 back to the bank. Why did the owner of the restaurant pay the bank $550 more than he borrowed? A says the $550 was a gift to the bank. Now, most people, no people, go around giving gifts to banks. That doesn't make any sense. So we're going to put an X on that one. B says the $550 was the sales tax that he had to pay on the oven. You don't pay sales tax to a bank. You pay sales tax in the store. It's going to be a part of the price once you get to the register. So it's not B. C says the $550 was the interest he had to pay for the loan. Well, that sounds about right. But if you don't know what that word interest is, or you don't remember what it is, because we covered it when we talked about financial literacy, interest is a fee that you have to pay for borrowing money. So if somebody loans you money, they don't just give it to you and say, okay, well, I gave you $5, you give me $5 back. Now, that might happen if you borrow it from your mom, but if you borrow it from a bank, then they say, okay, I'll give you this $5, but you have to pay me a fee for letting you borrow this $5. And that fee is the interest, okay? So It's looking like it's going to be C, but let's look at D. The owner must have forgotten that he only borrowed $6,000. Well, I'm not going to give you more money just because I forgot how much I borrowed from you. If anything, I will try to give you less. So it's definitely not D. So that means that our correct answer is C. Now, if that's not the answer that you received when you walked through this problem, then I want you to pause your video so that you can make sure that you're circling the correct answer. All right, let's take a look at question number 5. A math teacher wrote a number in expanded notation as shown here. 7 times 10,000 plus 6 times 1,000 plus 4 times 100 plus 7 times 1. What is the standard form of the number? F, 7,647, G, 70,647, H, 76,470, or J, 76,407. Now, pause your video. Draw a place value chart to help you solve the problem on your own. Then you can check your work as I model the problem. Let's reread. A math teacher wrote a number in expanded notation as shown here. 7 times 10,000 plus 6 times 1,000 plus 4 times 100 plus 7 times 1. What is the standard form of the number? Anytime you see a number written in expanded notation, the best thing to do is to draw a place value chart out on your paper. So, here's my place value chart. This is what yours should look like. A ones place, a tens place, a hundreds place, a thousands place with the comma, and a 10,000s place. Now, if you want to go up to 100,000s, that's fine also. Now, we're going to put these numbers in our place value chart according to the place value that it's multiplied by. So, if we look at 7 times 10,000, well, the number 7 is multiplied 10,000. So, that number belongs in the 10,000th place. So, we write 7 in the 10,000th place. When we look at the next number, 6 times 1,000, well, it's multiplied times the thousands place. So the 6 goes in the thousandth place. Next, we look at 4 times 100. Well, since 4 is multiplied times 100, then it goes in the hundredths place. And finally, we have 7 times 1. And since 7 is multiplied times 1, then that means that that 7 goes in the ones place. Now, you'll notice that we don't have a number multiplied times 10, which means the number 0 is going to go in the tens place. Now, we look at the number that we have in our place value chart and we compare it to our answer choices. When we compare it to our answer choices, we see that the number in our place value chart is 76,407. Which answer choice matches the numbers in our place value chart? If you said J, you are absolutely correct. So make sure you circle J. Now, I want you to go ahead and pause your video to make sure that your answer looks like mine. And if you did not draw that place value chart on your paper, please do so. And again, you have scratch paper attached so that you can use it to write these things out. Let's read question number 6. It says, Mr. Ellis is a dentist. Which factor most likely affects the amount of money he earns each month? Now, this is one of those questions where you have to pick the answer that makes the most sense. It's no math that you need to work this out. It's one of those I need to think about what makes sense and what doesn't. So, I want you to pause your video, think about what makes sense, and get rid of the answers that don't make sense at all. And that way, all you'll have left is the actual correct answer. All right, it's time for me to model question number 6. Mr. Ellis is a dentist. Which factor most likely affects the amount of money he earns each month? A says the number of other dentists he knows. Well, it's nice that he knows people, but that has nothing to do with how much money he earns. Let's look at B, the number of patients he helps. Maybe more patients means that more people are paying more money. So probably, let's keep that one in mind. Moving on to C, the number of dental tools he owns. Well, it doesn't matter how many tools he owns. He can own all the tools in the world. If he doesn't have any customers, he won't earn any money. So it's not C. And D, the number of children he has. Well, usually the more children you have, the more broke you are because you guys are expensive. All right, so no, that's not going to affect how much money he earns. It's going to affect how much money he has in his pocket. So the only answer that makes sense is B. Now, if you need to pause your video to draw those X's over those incorrect answer choices and circle letter B, go ahead and do so now. Let's take a look at question number 7. Question 7 says Yuki has 42 pebbles. She wants to put the pebbles in the pockets of her jacket. She wants an equal number in each pocket. If her jacket has 6 pockets, how many pebbles should she put in each pocket? F, 36, because 42 minus 6 equals 36. G, 48, because 6 plus 42 equals 48. H, 252, because 6 times 42 equals 252. J, 7, because 6 times 7 equals 42. Now, pause your video to try to solve the problem on your own. Next, you can check your work as I model the problem. Go ahead and get this problem modeled. Yuki has 42 pebbles. She wants to put the pebbles in the pockets of her jacket. She wants an equal number in each pocket. If her jacket has 6 pockets, how many pebbles should she put in each pocket? I see that word each, which means I need a get chart. Very good. Now, once I have my get chart, then I reread. Yuki has 42 pebbles. Okay, well, 42 sounds like a total to me. She wants to put the pebbles in the pockets of her jacket. All right, no information there quite yet. I know I have pockets. She wants an equal number in each pocket. Equal number in each pocket. Anytime you have an equal number of something in something, then that means you're going to divide. Okay, you're either dividing or you're multiplying. Usually it's dividing. Now, if her jacket has 6 pockets, how many pebbles should she put in each pocket? So that means the pockets are the groups because they ask you for the each. So you don't know the each. We write our equation. 6 times blank equals 42, or you can write it as a division equation. 42 divided by 6 equals blank. Now, if you know your sixes, then you know the answer. If you don't know your sixes, then let's make a ratio table. Now, I know my fives, and I know that 5 times 6 is going to give me 30. So I'm going to start my ratio table at 5. So let's go 5, 6, 7, 8. And I know that 5 times 6 is 30. Now all I have to do is add 6. So my goal is to get to my total of 42. 30 plus 6 is 36. And 36 plus 6 is 42. Well, wait, that's my total, so I stop and circle it. That means that the number next to 42 is my answer. Hi there, 7. 7's my answer. All right, so the only answer choice where 7 is the answer is J. And again, J says 7 because 6 times 7 equals 42. Circle J, that's your answer. Now you may want to pause your video to write down the same notes that I have to solve the problem if you did not get the correct answer on your own. So pause that video just to check your work. Now, we have completed homework page number 1, and we're moving on to homework page number 2. Let's go. Now, I want to make sure that you are actually looking at page number 2. So, look at the page on the screen. Make sure that you're on this page because this page is page number 2. So, make sure you're on page number 2 before we start going over the work on page number 2. Take a look at question number 1. A square is split into 6 figures as shown. Which figures are quadrilaterals? Now remember, quadrilaterals have only 4 sides. Exactly 4 sides. So is it A, figure 1 and 3, B, figure 5 and 6, C, figure 4 and 6, or D, figure 3 and 4? Go ahead and pause your video to try to solve the problem on your own. Next, you can check your work as I model the problem. Okay, let's go ahead and model this problem. It says a square is split into 6 figures as shown. Which figures are quadrilaterals? Now remember, quadrilaterals are shapes with exactly 4 sides. Exactly 4 sides. So let's start with letter A. Letter A says figures 1 and 3 are quadrilaterals. So let's count the sides on figure 1 first. 1, 2, 3, 4. Okay, so figure 1 is definitely a quadrilateral. It has 4 sides. Let's take a look at figure 3. 1, 2, 3, 4. So figure 3 is also a quadrilateral because it has exactly 4 sides. So we're in luck. Our first answer choice is actually our answer. So it's A. If you need to pause your video so that you can trace the sides on figure 1 and figure 3 and then circle A as your answer choice, go ahead and do so now. Let's take a look at question number 2. 3 students created models to represent numbers. Tyree's model, Ian's model, and Don's model. Okay, which models represent the same number? F says Ian's model and Don's model because 31s is equivalent to 3010s. Think about it. Is that true? G says Tyree's model and Don's model because 300 is equivalent to 3010s. Is that true? H says Ian's model and Tyree's model because 31s is equivalent to 300s. Is that true? And J says none of the models represent the same number. Is that true? Now, I want you to pause your video, solve the problem on your own. Next, you can check your work as I model the problem. All right, now it's time for me to model this question. Again, it says 3 students created models to represent numbers. Now, first, let's look at Tyree's model. What are those blocks called? Those place value blocks there. If you said 100 flats, then you are absolutely correct. So that means that each block or each flat in Tyree's model is worth 100. So I'm going to go ahead and label those. This one's worth 100. This one is worth 100. And this one is worth 100. So that means that Tyree's model is equal to 300. Okay. Now let's take a look at Ian's model. When I counted Ian's blocks, his model is made of all units, and each unit or each square is equal to 1. So when I counted those, then I was able to obtain the total of 30. Now, so far, Tyree's model is equal to 300 and Ian's model is equal to 30. Those are definitely not equal to each other. So let's take a look at Dawn's model. Now, those place value blocks, or base 10 blocks, that Dawn has used to represent her model are all 10 longs, which means each long is worth 10. So when I count, I ended up with 100 for this group, 100 of this group, and 100 for this group, because each group is made up of 10 tens, and 10 times 10 is 100. So that means that the total for Dawn's model is 300. Now, just by looking at my models, I noticed that Tyree's model and Dawn's model are equal to the same amount. And the only answer choice that says that Tyree's model and Dawn's model are equal to the same amount is G. But I want to make sure they're saying the correct thing. So I reread G, and it says Tyree's model and Dawn's model, because 300 is equivalent to 30 tens. Well, that's absolutely correct. 300 is equivalent or equal to 30 tens, because there are 30 tens in Dawn's model. Now, if you need to pause your video to label the base 10 blocks or place value blocks, whichever you call them, to make sure that you are modeling the way that I'm modeling or labeling your figures the way that I'm labeling my figures, go ahead and pause the video and do that now. Let's take a look at question number 3. Question number 3 says, Shane used a pencil to shade 1/2 of a square and 1/2 of a parallelogram. So they already told us that each model is equal to the fraction 1/2. Now, the question asks, do Shane's models show that 1/2 is equivalent to 1/2? So the question is, does the model that's shown here in front of us mean that 1/2 is equal to 1/2? Do these models show that? We know that 1/2 is equal to 1/2, but do these particular pictures show that? Okay. Answer choice A says yes, because both figures are quadrilaterals. Answer choice B says yes, because both figures are shaded with the same pencil. Answer choice C says no, because the square is more than 1/2 shaded. Answer choice D says no, because the area of the figures are not equal. Now, I want you to think about that. Pause the video. Go ahead and try to solve this on your own. Next, you can check your work as I model the problem. Now it's time for me to model this problem. Again, it says Shane used a pencil to shade 1/2 of a square and 1/2 of a parallelogram. Do Shane's model show that 1/2 is equivalent to 1/2? Let's look at answer choice A. Yes, because both figures are quadrilaterals. Well, while they both are quadrilaterals, that doesn't have anything to do with 1/2 being equal to 1/2. I want you to pay close attention to the size of the figures. So it's definitely not A. All right, let's look at B. B says yes, because both figures are shaded with the same pencil. Well, that doesn't have anything to do with it. Okay, nothing. The type of pencil that you use to shade a fractional unit has nothing to do with the size of the fraction or the size of the shapes. So that's not it. Let's take a look at C. C says no, because the square is more than 1/2 shaded. Well, that's false. That square is not more than 1/2 shaded. So that's not it. Which means that the only answer choice that makes sense is D. D says no, because the area of the figures are not equal. And that's true. That square is smaller than the parallelogram. So that means that the answer is D. Now, If you did not arrive at the same answer, then you may want to pause your video to go ahead and circle the correct answer. Let's look at question number 4. Question number 4 says, which comparison and explanation are true? So you have a blank fraction strip model here, okay? Now, the answer choices are A, 2/6 is greater than 2/3 because 6 are larger than thirds. You have to think about it and look at the model to help you. Is that true? B says 2/6 is less than 2/3 because thirds are larger than 6. Look at the model. Is that true? C says 2/6 is greater than 2/3 because 6 are larger than thirds. Look at the model. Is that true? D says 2/6 is greater than 2/3 because thirds are larger than 6. Look at the model. Is that true? Now I want you to pause your video and try to solve the problem on your own before you work with me to check your answer. All right, it's time for me to model question number 4. Which comparison and explanation are true? Well, before I start modeling, we need to take a look at this blank fraction strip that we're given so that you can know exactly what you're looking at. All right, that very first line at the top, that's representing one whole because that's a whole rectangle, right? So it's a whole rectangle. Now, each one of these lines represents a whole, but it's divided into different amounts. So that first line is one whole. Notice it's not divided into anything. Now let's look at that second line. That second line is divided into or partitioned into 3 parts, which means it's partitioned into thirds. So each unit of this whole rectangle that's divided or partitioned into 3 parts is equal to the unit fraction 1/3. Now let's look at the third line. The third line is partitioned into how many parts? That's right. If you said 6, you're absolutely correct. So since it's divided or partitioned into 6 units, then that means that each unit is equal to 1/6. So now you should have yours labeled like mine. And now we can start comparing. Okay, so 2/6 is greater than 2/3. Well, let's look at it. Are 2/6 bigger than 2/3? Absolutely not. So we can go ahead and put an X over answer choice A. Now let's look at answer choice B. Answer choice B says 2/6 are less than 2/3. Well, if you look at it, 2/6 are smaller than 2/3 because thirds are larger than 6. So that's correct. Now, before I circle my final answer choice, I'm just going to walk through the other ones just to make sure that that's the best answer. So when looking at answer choice C, it says 2/6 is greater than 2/3. Well, we know that's not correct. If I have 2/6 and I put them against 2/3, then the 2/3 are always going to be larger than the 6. So it's not C. And looking at answer choice D, here we go again. 2/6 is greater than 2/3. That's not correct. 2/6 will never be greater than 2/3 because thirds are larger than 6. So that is not correct, which means our actual correct answer is indeed B. Now, if you need to pause your video to label that blank fraction model, go ahead and do so now. And if you need to make sure to circle your correct answer choice, do that now. Now, we have completed homework page number 1, homework page number 2, and now we're on homework page number 3. Let's get started. Since we're on homework page number 3, I want you to take a look at the page that you're on now to make sure that it matches the page that's on the screen. The page that's on the screen is homework page number 3. So please make sure you're on homework page number 3 before we get started going over these questions, because I want to make sure that you're looking at the correct page. Let's take a look at question number 1. Question number 1 says the model represents a set of 6 plastic cups. which two fractions can represent the gray counters in the group? So there are two fractions that can represent these gray counters. Answer choice A says 2/4 and 2/6. Answer choice B says 1/4 and 2/6. Answer choice C says 1/3 and 2/6. And answer choice D says 2/4 and 1/3. I want you to go ahead and pause the video to try to solve this problem on your own. Next, you can check your work as I model the problem. All right, let's go ahead and solve this problem. So it says the model represents a set of 6 plastic chips, which two fractions can represent the gray counters in the group. So you might be saying, Ms. Jones, I only see one fraction. There are two, and I'll show you. So first, we need to look at the total amount of counters that we have, right? We have 6 total counters, and that's going to be our denominator. Then we write a little fraction bar, and then we take a look to see how many counters are gray. Well, when we count them, there are 2 shaded counters that are gray. So for sure, one fraction that can represent this model is 2/6. But it's like, okay, well, it's only one fraction, Ms. Jones. They said 2. All right, well, let's take a look at how we figure out the other fraction. But first, we can get rid of one of our answer choices. We can go ahead and get rid of D, because 2/6 is not one of the fractions that's represented by answer choice D. So now we're down to 3 answer choices. Okay, I like models like this because if you cover up half of the model, then you're able to figure out the equivalent fraction or the other fraction that can be represented by the model. So if you cover up the bottom half of the model and look at it, now the fraction that's shown is 1/3. So that means that the two fractions that can represent or be represented by this model is 1/3 and 2/6. So it's not B, it's not A, but it's C. And in order to check your math, if you add 1 plus 1 is 2, 3 plus 3 is 6, that means that 1/3 is equivalent or equal to 2/6. So if you count by ones in the numerator and count by threes in the denominator, you'll still end up with 2/6. That's how you know that these fractions are equal and this is your answer. Now, if you need to pause your video to write some notes like I have on my screen, go ahead and do so now. For this question, I'm just going to read it to you. If you don't have a ruler at home, I suggest that you do this one in class because we have a lot of rulers, but I'll go ahead and read it. It says use a ruler to measure the length and the width of the rectangle to the nearest centimeter. So you're going to be measuring one long side and writing down the length and one short side and writing down the length. And you're going to be doing that in centimeters. And it says which measurement is closest to the perimeter of the rectangle. So you write down the long side, write down the short side. And remember, the sides that are across from each other or congruent are equal, okay? So if you don't have a ruler to do that at home, it's okay. You can do that here at the school. And for perimeter, you have to add up all the sides, all 4 sides once you measure them. And that's it for this question, because if you don't have a ruler at home, then I don't want to give you the answer. So if you need to do this one at school, just let me know and we can do this at school. Let's take a look at question number 3. Question number 3 says, which answer choice does not describe the number 5,230? So when it says not, remember, you're looking for the wrong one. That means that all of these answer choices describes the number 5,230 except one of them. Okay? So what I normally do with questions like this is I create a place value chart, and then I plug in the information so that I can see which ones are correct or incorrect. So I want you to pause your video, try to solve the problem on your own, and then you can check your work as I model the problem. All right, let's go ahead and model this problem. So again, it says which answer choice does not describe the number 5,230. So you want the answer choice that is wrong. You want the answer choice that is not 5,230. So 3 of these answer choices are going to be 5,230, and one of them is not going to be 5,230. So I have my place value chart, and I'm going to put each answer choice in my place value chart to see which one is not 5,230. So I start with A, 5 thousands and 23 tens. Well, I know that 10 tens is 100. And if I have 23 tens, then that means that if 10 tens is 100, then 20 tens is 200. So I unbundle, and now I end up with 5,000, 200s, 3 tens, and no ones. So since answer choice A is equal to 5,230, that's not my answer because it needs to not equal 5,230. So let's look at answer choice B. 5,000s plus 200s plus 31s. Well, I can't put 31s in the ones place, so I need to unbundle. Well, I know that 10 ones is a 10. So if 10 ones is 110, then 30 ones is 3 tens. Well, it cannot be answer choice B because that also equals 5,230. Let's move on to answer choice C. So we have 5,000s, 200s, 3 tens, and 0 ones. Well, answer choice C also is equivalent or equal to 5,230. Looks like the only one we have left is D, but let's check it to make sure. 5,000s, 200s, 30 tens. Well, remember, we have to unbundle that. If 10 tens is 100, then that means that 30 tens is 300. So 300s plus the 200s that were already there is 500. So I end up with 5,500, and that's it, which means that answer choice D is the only answer choice that does not describe 5,230. Now, if you need to pause your video to make notes and create this place value chart like I have on my screen, go ahead and do so now. Let's take a look at question number 4. Question number 4 says, the table shows how many hours of television that 19 students watched last weekend. This is a tally chart. Which dot plot summarizes the information in the table? Now, make sure you pause your video, try to solve this problem on your own. After you try to solve it on your own, you can check your work as I model the problem. Time to model question number 4. Now, it says the table shows how many hours of television that 19 students watched last weekend. So if we look at the table, it says number of hours, number of students. So on the first line, the number of hours, 1. So how many students watched television for 1 hour? 2. So that means that I should have 2 dots above the number 1. The next line says number of hours, 1.5, and that's 5 tally marks. So there should be 5 dots between the number 1 and 2 on your dot plot below. The next line says 2 hours. So there should be 3 dots above the number 2 on one of those dot plots below. The next line says 2.5, and there are 5 tally marks there. So there should be 5 dots between the numbers 2 and number 3 on that dot plot. Finally, there are 3 hours. So there were 4 students that watched television for 3 hours. So there should be 4 dots above the number 3 on one of those dot plots below. So let's look at answer choice F. All right. There are 2 dots above the number 1. Okay, it's looking good. Now, in between the number 1 and 2, where 1.5 is, there should be 5 dots. There are only 4 dots, which means answer choice F is not our answer. Let's look at G. There are 2 dots above the number 1. Looking good. Above 1.5, which is between the 1 and the 2, there should be 5 dots. Okay, that's perfect. Now, above the 2, there should be 3 dots, but there are 5 dots. So that's wrong. It's not answer choice G. Let's look at H. All right, there are 2 dots above the number 1. That's correct. There are 5 dots above 1.5. That's also correct. There are 3 dots above the number 2. There are 5 dots between the 2 and the 3, which is 2.5. And there are 4 dots above the number 3. So that means that answer choice H matches our frequency table with our tally marks, okay? Now, let's look at J, just to look at it. Now, we can look at J and tell it's already very, very wrong. There's only 1 dot above 1, 1 dot above 1.5, 2 dots above 2, 1 dot above 2.5, and 3 dots above 3. So that is very, very wrong, which means the only answer choice that matches our tally chart is answer choice H. Now, on your loose leaf paper that I attached to your homework, make sure you write these notes about the tally chart, because going ahead and writing down what each number of hours, the amount of dots that you were supposed to have, that helps us to solve the question quickly instead of having to keep looking back and forth between the answer choices and the table. So if you need to pause your video to write down your notes, go ahead and do so now. Number 5 says, which unit of measurement is likely to be marked on the side of a large container of juice? Okay, so on a large container of juice, how do you measure juice? Do you measure juice in A, liters, B, pounds, C, kilograms, or D, meters? Go ahead and pause your video, think about it, try to solve it on your own, and then you can check your work as I model the problem. All right, it's time for me to model question number 5. So before I model question number 5, or really in order to model question number 5, we have to look at examples of each type of measurement. So this is an example of what you would measure in liters, like a 2-liter soap, okay? So liters measures liquids or capacity, okay? The liter unit is used when measuring volume. Now, let's take a look at an example of pounds, right? All right, a pound is a standard unit used to measure the weight of an object, like bread. You weigh bread by the pound. All right, 1 pound is equal to 16 ounces. Here's an example of kilograms. All right, so with kilograms, basically it's used to measure weight, usually of smaller objects. And finally, meters. Meters are used for measuring and comparing length, like a meter stick, which is like one of those really, really, really long rulers. Okay, so these are examples of the different measurements: liters, pounds, kilograms, and meters. So looking at these pictures, which one makes the most sense for you marking on the side of juice? If you said liters, you're absolutely correct. You would be marking on the side of a large container of juice using the measurement of liters. Now, if you need to pause your video to maybe write down the definitions or the examples of the different types of measurement, go ahead and do so now. Congratulations, you have finished your STAAR Homework number 2 packet. Give yourself a round of applause. Yay! All right, this is Miss Math Jones saying I will see you tomorrow at school, and have a great rest of your day or evening whenever you're completing this assignment. Bye.